good afternoon, good evening, whatever the case may be. We are back in better than ever, and everything is magic indeed, as sung by the great angels and airwaves. So let's get to it, shall we? Because today we are discussing circles and some exercises that we can do, that we can explore, some relationships. Awesome. All right, angle in a semicircle. We know that if we inscribe an angle in the semicircle, remembering that inscribe in a semicircle means that the sides of the angle intersect the endpoints of the diameter, or you can think of it as inscribing a triangle in a semicircle. It shall always be a right triangle, and we talked about this in class. If you look here, got myself a triangle inscribed in the semicircle, meaning the hypotenuse is a diameter of the circle. So no matter what, I wonder if I can move this around. I don't think I can. Can I move that? Yeah, I can. No matter what, no matter where the diameter is, and no matter where this point is, I'm going to have a 90-degree angle. And that is quite helpful in answering some questions. So let's get to it. A circle has a diameter xy, so let's get a circle going here. Boom, oops, that's not a circle. What happened? All right, here's our circle. There's our circle. Let's see, we're going to need a center, so we'll put that right there. And we need the diameter, right? So let me go to my line tool. Bang. There's my diameter. Okay. Of length 13, Z is a point on the circle such that XZ is 5 centimeters. Okay, so let's go ahead and label some things. We have X, we have Z, nope, we have Y. XY is the diameter. And then we have any point on the circle. Tell me when to stop, Mrs. Humphrey. Tell me when. Yell it.
Now.
Now, right there. So Z is going to be here. And clearly it's not the scale. Actually, it is. No, it's not going to be the scale, but we don't care. So we are told XZ is 5 centimeters. So that's from here to here. And we are asked to find the length of YZ. So let's label everything that we know. We know that the diameter is 13, that XZ is 5, and we are looking for the length YZ. I'm going to call X. And we also know that we have an angle inscribed in a semicircle, so it must be a right angle. So we can use our friend Pythagoras. You should already know the answer. This is a very common Pythagorean triple, or a very common set of side lengths to form a right triangle. So I know that x squared plus 5 squared is equal to 13 squared, that x squared plus 25 is equal to 169, x squared equals 144, and x equals 12. So I know that YZ is equal to 12 centimeters. Again, 5, 12, 13 is a Pythagorean triple, 13 being the length of the hypotenuse. So if I have a hypotenuse of 13 and either a 5 or a 12, I should immediately know the other length. Let's move forward, shall we? Chord of a circle. Remember, a chord is a line segment whose endpoints lie on the circle. If I draw a radius perpendicular to a chord, it bisects the chord. Bisecting means it's going to divide it into 2 equal segments. And of course, if I draw radii to the endpoints of that chord, I've got myself an isosceles triangle. So let's see what we can do with that. These are fairly straightforward. We're just laying the groundwork here. A circle has a chord of length 10 centimeters. Let's draw that puppy. Boom, 10 centimeters. If the radius of the circle is 8, so I'm going to need a center here. Yes, find the shortest distance from the center of the circle to the chord. Well, the shortest distance is going to be, from the center, is going to be perpendicular to the chord. And I also know the length of the radius is 8. So let's see how that's going to work out. So I know this is 8. If I've drawn it perpendicular, I'm going to put a right angle here. It has bisected this chord. And I was told that this entire length is 10. So I know that this is 5, and I'm looking for x. Lo and behold, I've got another right triangle. I can use my good friend Pythagoras. X squared plus 5 squared is equal to 8 squared. X squared plus 25 is equal to 64. So that means x squared is going to be equal to, I believe that's 39. Why would I be wrong? I'm never wrong. X is equal to the square root of 39. Notice I did not put plus or minus, nor on the previous exercise, because we were talking about distance, so a negative answer does not make sense. This is approximately equal to 6.24, but I prefer an exact answer of the square root of 39 centimeters. All right, giddy up. Next, we know that if we draw a tangent line to a circle, so from any point outside the circle, they just chose convenient here, and you see this tangent line, which could go on forever and ever, but we're only interested in the tangent from the point to the point of tangency, right there. If I draw a radius to that point of tangency, then I have a right angle. That's always going to be perpendicular. So let's see how that can play out on a question. Here we go. Got myself a circle. A tangent of length 10 centimeters is drawn to a circle. So I don't know, maybe I'll draw one here. Oops, that's a circle. Let me go to my line tool. And here. Okay, so I'm going to draw a tangent line there, and I'm going to draw my point of tangency. It appears to be right there, and here's the center of my circle approximately, and it tells me a tangent of length 10 centimeters. So let's be clear that that length is from the end point to the point of tangency. This is 10. With radius of 7 centimeters, how far is the centra of the circle from the endpoint of the tangent? Well, let's draw in some things. They want to know what that length is, and the radius drawn to the point of tangency is going to help me immensely because it's perpendicular, and I also know that the radius is equal to 7. This is my x. Don't you love Pythagoras? X squared is going to equal 7 squared plus 10 squared. X squared is going to equal 149. So my length x is going to be the square root of 149, and we're still in centimeters. So that's the distance from the center to the point of tangency. No. To the end point of the tangent. All right. One last little exercise here. I'm going to make this even bigger, I think. So I got 2 circles here. I want to make it bigger. Now we need the writing. Let's see. Oops. I want to make it as big as I can. Okay. So I've got 2 circles have a common tangent with points of contact at A and B. Okay, so we've got that. And the radii are 4 centimeters and 2 centimeters respectively. So let's draw those. So let me estimate the centers of my circle. Maybe here. Oops, need the pen. Here and here. Okay, and let's draw a radii to that point of tangency. You know we're going to use that here and here. And we know that these are 4 and 2 respectively. Find the distance between the centers given that AB is 7 centimeters. So let me just move that over so you can see it. Find the distance between the centers given that AB is 7 centimeters. So I will label that for us. AB is 7. And they want us to find the distance between the 2 centers, which I am going to call, I'm going to get crazy, and I am going to call it X. Okay. Well, we know these are perpendicular here, that this is a right angle, and this is a very nice strategy you can use with this type of question. We know it's perpendicular because it's a radius drawn to a point of tangency in both instances. So watch this action. What I'm going to do is draw a line from the center of the circle with the shortest radius, and I'm going to draw it parallel to AB. Parallel to AB. Okay. Well, if it's parallel to AB, sports fans, what I've done is drawn myself a nifty rectangle. Yes? And from A to B is 7. So if I call this X and I call this Y, from X to Y must also be 7 because it's a rectangle, right? And from B to Y, well, that's the same as A to X. So this must be 2, which means from X to the center of the circle is also 2. And lo and behold, all of a sudden, I've got a right triangle where I can easily solve for x. So I can now say that x squared is equal to 2 squared plus 7 squared. So that's going to be x squared is equal to 49 plus 4, which is 53, and x equals root 53. So the distance between the two centers is square root of 53 centimeters. Isn't that beautiful? Well, I hope you enjoyed it. I certainly did. Let's go ahead and see how Angels and Airwaves is doing as we sign out. And with that, I am